In our next session for Firepower Threat Defense, we will talk about two special policies, and I am going to start with QoS. The only QoS method available on FTD is rate limiting or just policing. As of the current code, it is not possible to use traffic shaping or maybe congestion management mechanisms. And what we can enable is going to be just to police the communication. The QoS policy is only going to come into play when our traffic matches allow or trust role in the access control policy. Of course, when we block communication or maybe possibly do what is known as pre-filtering, which is what we will take a look at later in this session, the traffic is not going to be affected by QoS. So if you want to police communication, you will first and foremost have to make sure that the packets are allowed or trusted in the ACP. There's going to be just one global QoS policy that you can push to your FTD sensors. This might change in the future, but right now we have just one policy that we can define on the device. If we plan to use one, this is what we will configure under devices and then QoS. And for verification this time, ideally what we should use is going to be show service policy on the ASA's CLI. Maybe let's quickly take a look at this. What I will try to show you here is going to be simple rate limiting configuration for ICMP communication. So we will be generating a bunch of pings from R2 to R4, and this is where we will enforce our QoS policy. Okay, we already have a role in the access control policy. This is actually a leftover from the previous session. We have two roles. I allow ICMP communication, and we also allow telnet packets from the inside to the outside. ICMP is permitted in any direction. So we should be able to ping from 2 to 4. I will try to get to the loopback of 4. Okay, we see we have connectivity, and we will now enforce our QoS policy. So we will go under devices QoS. As you can see by default, there is no policy available. I'm going to call it my QoS, like that. Just let's go for lowercase QoS. And I will say that this is going to be for this device. We will save. And we will now add a single role inside of this policy. So this is the role structure. You can give it a name, like I will say police ICMP. We will apply the policy on the source interface. So this is going to be incoming interface where we will specify the limit. And we can either do a limit for the outbound or inbound direction. Like when you say upload, it means that you want to affect incoming packets. Versus when you say download, this is going to be for the outbound direction. Okay, what I will do here is that we will enforce this policy on this particular interface, and we will do this in the inbound direction. So I'm going to configure the limit for the upload option. Let's just say 1 meg per second. And this is my source interface. Okay, and this is going to be specifically for ICMP communication. So I will just use the protocol option here. We will go for all ICMP packets. Okay, no port number in this case. I'm going to click on OK. And let's also verify this role once again. So this is the source interface, and this is for all ICMP packets. Okay, 1 meg per second inbound. We will save and we will push this change. Okay, so as a result of that, what we should see here is that when we then ping from 2 to 4, like let's say, let's send a large number of packets that are going to be pretty long. 1500 bytes. And I'm gonna say that the timeout is gonna be 0. Maybe let's just first send 1000 packets, because we still have to wait for the policy to be activated on FTD. It doesn't appear that we have a problem now. We need to wait for the policy to get deployed. Let's say show run service policy on FTD. We are still with the global policy. This change didn't take effect. Now it took effect. So we will do this test once again. And maybe this time I'm gonna increase the repeat count to be something higher than just 1000 packets. So we can see that there is gonna be some delay as the packets are being dropped, like in this case, and in this case. And I'm gonna verify this configuration on the FTD CLI, on the ASA's mode, and we will just say show policy map, or just show service policy, I should say. And this is gonna be for policing. So we see that a certain number of packets exceeded our limit, which is 1 meg per second, inbound on the inside interface, and those packets were dropped. Okay, for the remaining portion of this session, we will now focus on a different policy, and known as pre-filter. And this is something that we can use, enable on Firepower to exclude communication from advanced inspections. Now, what it means is that roles that you will build inside of the pre-filter policy, that they will be evaluated before any of the access control policy rules. And those rules will be enforced at the LINA level, so at the ASA level. And one of the key things to remember about this, the policy and that type of rules, is that they will be affecting packets based on layer 3 and layer 4 information only. So this is what is gonna eventually allow FTD to process packets without any additional latency, without an additional delay in a performance-friendly fashion. Just to recap where pre-filtering actually fits in the packet processing, this is gonna be this portion of that FTD's workflow, packet processing workflow. As I'm gonna explain just a couple of minutes, it is still possible to block communication at this point. So you could technically use this policy to block packets, but it's not something that is actually recommended. In most cases, we will be using it to put packets into that special fast path, which is how we trust the communication and bypass all other inspection engines. Notice that packets that will be fast path, they go directly to the flow update portion of the LINA code. We bypass the data acquisition portion, which means that Firepower engine is not evaluated. Now, the individual engines that are part of the Firepower, they are not active for this flow. So the packet is going to be technically still evaluated by few features, but those features will be enforced at the ASA level. It is going to be possibly network address translation or maybe a VPN encryption. Then we will route the packet and finally send it down to the network. The QoS is not going to be enforced because QoS is enabled at the Firepower level. Okay, what might be somewhat confusing at this point is that pre-filter rules are actually configured inside of ACP. This is where you enable the feature. But once the rules are in place, they are pushed down to the LINA engine, and this is what eventually allows for a bypass for not invoking those special engines that are part of the Firepower processing module. Okay, now the question is when a feature like that might be actually useful. So there are going to be actually two, maybe three main use cases where you would want to use pre-filtering policy. One is going to be when you work with latency sensitive flows. For example, stock exchange. Like when you don't want to introduce an additional delay caused by those subsequent engines, by processing by those subsequent firepower engines, you want to transmit the packets as soon as possible through the FTD unit. That would be one example. Now, another example is when you work with large amount of packets, like backup communication, very large flows that are also known as elephant flows. So stuff like replication, this is something that you don't really want to push through FTD. This traffic is generally trusted, and you don't really want to process those packets with those special engines. You don't want to use IPS, you don't want to use authentication, check for authentication, do security intelligence, stuff like that. It's not needed. You just want to move those packets as soon as possible. Okay, the same might also apply to control plane, like maybe when you do BGP across the FTD. And then another major use case is going to be when you are dealing with tunneled packets. Okay, so what is going to be that benefit of using pre-filtering policy on the tunneled communication? If you think about most of the security appliances, the way that they process tunneled communication is in most cases based on the outer header data. So like when we have a simple GRE packet, this is going to be our outer IP header. Then you will have the GRE encapsulation, and assuming that we encapsulate an IP packet, this is going to make our inner header, and finally the payload is going to follow. So most of the appliances, they will be looking at this information. But this is not the case with FTD's access control policy. Access control policy is going to be always looking at the innermost detectable header. So in this case, we have just two, outer and one internal. So it is going to be looking at this header. But if we had multiple levels of headers, like if this was another IP, maybe somewhere here, it will be always trying to fall back to the rightmost header inside of the packet. Just to give you that ability of being very granular with what you will control. The only exception is actually the communication which is encrypted. In this case, we will be looking at the header which is in clear. This is going to be the outer header. But in all other cases, ACP is always going to be looking at those internal structures. And this is good because, again, it gives us that flexibility as we build our policies. But the drawback is that it might take a lot of additional resources, especially when there's going to be a lot of tunnels traversing through the FTD unit. So this is going to be another use case when you might actually want to use pre-filtering rules, because another important thing about those rules is that they work on the outer header information only. So when the pre-filtering engine sees a GRE packet, it is always going to be looking at the outer header. It is going to ignore the internal header of data. And this is, of course, what allows FTD to pass those packets pretty fast without hitting the performance. When we eventually get to the point when we will want to build our custom pre-filtering policy, there are going to be two types of roles that we will be able to choose. The role can be type of a tunnel, or the role can be type of pre-filter. What is going to be the difference between the two? So tunnel rules, this is what you will generally use to match clear text tunnels, like GRE, like IP in IP, like Toledo tunnels. You have those conditions available for selection when you use the tunnel type of a rule, and this is generally used to control tunnel communication. Those rules can be configured as unidirectional or bidirectional, where the difference is that when you say bidirectional and specify communication, let's say from A to B, with a bidirectional rule, it is going to affect packets flowing in both directions. So even that you find the rule to be unidirectional, it is also going to immediately affect packets returning from B or just flowing from B to A. Unidirectional is obviously for just one direction. Okay, this type of a rule also supports what is known as rezoning. which is just a method of assigning tunneled packets to a new security zone, which zone can be then used in your access control policy as a condition. So for example, like when you build a tunnel pre-filter role to match all GRE communication from A to B and also from B to A, like bidirectional flow. And then you said that you want to rezone this communication to a special zone, let's say GZ. Then when you get to the access control policy, you will be able to build a role that is based on that GZ zone rather than, let's say, inside, outside, or whatever else those endpoints belong to. So this is how we can easily tell ACP that you want to do something special with tunnel communication that was initially pre-filtered. Note that in this case, communication is not going to be actually dropped. It is not going to be allowed. It is still going to be evaluated by the ACP, and we will talk about the different pre-filtering actions in just a moment. The other of the two types, a pre-filter role, this is something that you will generally use for non-tunnel communication. So this is going to be useful like when you want to match those trusted flows, maybe elephant flows, low latency communication, latency sensitive traffic. This is where you will be able to choose your layer 3, layer 4 conditions, maybe even VLAN tags. You can use security zone, different protocols, port numbers, and so on. Now in this case, the pre-filter role is always going to be unidirectional. So if you want to match both directions, you will have to build, possibly add 2 roles to the policy. Okay, now in terms of the actual actions that we will be able to activate in a pre-filter policy rule, we can simply block the communication without any further inspection. So this way you can quickly drop the traffic without any additional processing. But this is not a recommended way of dropping communication. As I said initially at the beginning of this session, stuff like this can be still dropped inside of your ACP for a simple layer 3-4 condition. A pre-filtering is generally meant for fast pathing communication. Okay, we can say that we want to analyze, which is still not fast pathing. When you say analyze, it means that you want to pass the communication to the ACP for further evaluation. So in this case, we still don't drop or don't fast path packets in this role. So why something like this can be actually useful? Well, case number 1 is when you want to rezone a tunnel. That would be one example. Now, another example is when you will want to make an exception to a broader fastpath rule. And of course, fastpath is how you will enable pre-filtering. And as I said, the result of enabling a fast pathing is going to be complete bypass of all other inspection engines, including access control policy rules, all engines, security intelligence, authentication, SSL, QoS, network discovery. Everything at the firepower processing module is going to be bypassed when you fast path communication. Now, if you recall from one of the previous sessions, the access control policy offers a similar tool. This is known as a trust action, but there are going to be a few differences between access control policy trust and pre-filtering fast pathing. Okay, difference number 1 is that the ACP trust action, it in fact bypasses deep packet inspection and network discovery policies, but traffic might be still inspected by other engines, like security intelligence, authentication, and QoS in particular. Now, the second difference is that a pre-filtering policy is generally built based on layer 2 to layer 4 conditions. The access control policy, it gives us more options. We can go up to the application level. We can use the identity information as we build our policy. And finally, don't forget that access control policy works on the internal header versus pre-filter policy works on the outer header. And we will take a look at configuration of pre-filtering in just a moment. Just remember that the policy itself is invoked inside of access control policy. And as a side note here, a pre-filter policy is going to be generally global to the ACP. Like when you have multiple ACPs, you can potentially have different pre-filter policies, one for each ACP. And ACP by default is going to be using this default pre-filter policy if you don't have a custom policy assigned. And this is something that is actually very important to understand because the pre-filter policy consists of several rules. And those rules are meant to affect tunneled communication only, where the default action is configured to analyze, which means that we will pass those tunnels to the ACP for further evaluation. You can change the default action. You can set it to block all tunneled packets. Okay, if you want to build a new policy, you will go under Policies, Access Control Pre-Filter, and then you will have to activate this new policy under Advanced Settings of the ACP. Let's go ahead and take a look at this in our network. And we will first take a look at the default pre-filtering policy. I'm gonna say Policies, Access Control. And you will then choose our, maybe let me delete the block policy. This is not needed. You will only use this custom policy ACP. I'm going to open this policy for addition, and you will take a look at Advanced tab over here. If you look at this section, pre-filter policy settings, we see that there is actually one policy, default pre-filter policy, what we use by default. Okay, we can change the settings from here. Like I can select my custom policy, or I can edit settings of this default policy. Maybe let's first take a look at this default policy. As I said previously, it's going to be pretty important to understand what it actually does. It only consists of a one role here in the GUI, which is going to be the default action. So you cannot actually add roles to this policy. You can only change the default action, which is analyze all traffic, pass all tunnels to the ACP. And now all tunnel traffic is actually, if we take a look at this on the FTD, show run access list. Remember that the pre-filtering roles, they are pushed down to the underlying Lina engine, where the underlying Lina engine uses this access list, this global access list, to enforce the policy. And this access list generally consists of two sections. We have the pre-filtering section, which is our default policy. I'm going to say PF. And then everything else down to this line, advanced deny IP any. This is going to be our access control policy rules. So pre-filtering rules, they are, of course, processed before ACP rules because they are higher in the policy. And as you can see, those rules are initially set as advanced permit. Those rules will be always deemed as advanced, where the default permit means that we will again analyze the communication. So we will pass it down to the ACP rules. And notice what's going to be analyzed. It's going to be IP in IP, IP protocol 41, GRE. So all those default tunnels like Toledo, this stuff is going to be by default analyzed by the access control policy. And remember that access control policy in turn, it works on the innermost header. Those rules, like for example, ICMP. Okay, so what that means is that with our access control policy, I'm going to open this policy over here. We will take a look at the rules again. We have permit ICMP from anyone to anyone rule. This is rule number one in the policy. if we were now to go to router 1, the QoS is still here, but it's not going to affect this communication. This is not a problem now. I will be pinging from 2 to 4. Of course, this communication is affected by this role in the access control policy. Not a big deal at this point. But how about if I were now to build a GRE tunnel? I'm going to configure GRE between 2 and 4. And what is going to be a result of this configuration as the packets will be traversing via the FTD? What is going to happen? Let's take a look at this, because I want to show you this default interaction between the pre-filtering policy and ACP. So I'm going to go to 2 and I will say interface tunnel 12. You'll give it an IP address from 10.12.12 subnet /24 tunnel source. Let's say that this is going to be my loopback, and destination is going to be loopback of 4. And then on 4, the same subnet, just a different address. This is going to be my source, and this is going to be the destination. Okay, so what is going to be the end effect of this configuration? How about if I were now to ping from 2 to 4, but within the tunnel? So I'm pinging across the GRE tunnel. I'm trying to get to the other end of the tunnel interface. And we see that this communication is allowed. Why is this the case? It's technically GRE. What now goes via the FTD and not ICMP? Remember about this default pre-filter policy. It says, I'm okay with tunnels including GRE, just pass them on to the ACP. We go to the ACP, there is still no role for GRE packets, but remember again that ACP works based on the internal header, not based on outer headers. And what's going to be the internal header in our case? It is, of course, ACMP. Okay, the logging is disabled for both these roles, so we will not see this in the connection event. But I can actually enable logs. We can change it just to show you that it is eventually going to show up. I'm going to save. And we will deploy. So remember about this default policy. It is here, and it affects communication. Tunneled communication, at least. Okay, let's wait for this change to propagate. And maybe in the meantime, I'm also going to create my custom policy, because this is eventually what I want to show you. We will take a look at 1, maybe 2 roles. How do they affect communication? So I'm going to say build a new policy. My PF is going to be the name, like my pre-filter. And this is where I can now add the roles. Okay, go back to the FTD before we will start adding those roles. Did it log? It's still not logging here. We need to wait until it finishes. Okay, let's just send a bunch of pings here. And let's go to the event viewer. So my expectation now is that we will see a connection from 10.12.12.2 to 10.12.12.4, which is here. It says this is allowed, this is ICMP, traffic. And if we take a look at the details, it is going to show us the pre-filtering rule, pre-filtering policy that was applied to this flow. So this is my access control policy, and this is the default pre-filtering policy, what is also a match for this flow. So it shows me the default pre-filtering policy because it is technically GRE tunnel. It's just ACP what sees the internal headers. Okay, so going back to our custom policy, we will now add two rules. One I'm gonna say is to block GRE communication between R2 and R4, or just say GRE block. And this is gonna be for both directions. I'm gonna build a bidirectional rule. Okay, I will not be doing any rezoning. This is not needed. I just want to block this communication. The rule is gonna be enabled, and my tunnel endpoints is R2, and the other one is gonna be R4's loopback. So I am adding these. It doesn't really matter what I say is the source, what's the destination, because the rule is gonna be bidirectional. And for encapsulation, it is just for clear text GRE. Okay, so say add, role type is tunnel, communication between these two, GRE. We know that this is going to be bidirectional, and we want to block. I'm going to say save, and you will then deploy this change. Why is it not showing me the FTD unit? Okay, I didn't assign this policy to the sensor. You still need to go to policies, access control, and change the advanced settings inside of this policy. Because remember, now it uses the default policy, not the custom one. So I gotta activate it. Go to advanced, pre-filter policy settings, and change this default policy. MyPF. Let's save and deploy. Okay, so we see that the policy name has changed. It is now called MyPF. And we have a role which is blocking GRE tunnel between 2 and 4 bidirectionally. So when I now ping once again, we should see that this is going to be blocked. Now we see that the flow is allowed because we still have a connection from the previous session. I'm going to clear stateful table. And now we see that it is actually blocked. And this is something that we will also, we would also see in the log messages if I were to log this flow. Okay, the other role that we will now build is going to be type of pre-filter. So I'm going to add this policy. And we will add pre-filter role this time. Let's say that this is going to be telnet to 8080 from the inside to the outside over port TCP 8080. And this time we will say we want to have fast path. That's how I'm going to make exception to the access control policy. And maybe let's also quickly enable logging here. Okay, save, push this change from the inside to the outside just in one direction. Let's wait for this change to propagate. Okay, we see the role eventually showed up. It is over here, from the inside to the outside over port 80, and the role is marked as advanced trust. So this is how we enable fast pathing. Telnet to 4 from the inside to the outside over port 80. Maybe let's enable this. I'm gonna enable web server on router 4. And we will set the port to match this number. Okay, we see we have connectivity. And I just want to confirm this in the logs. It should be shown as a fastpath rule. Which is here. So for this connection, no additional inspections were taken. We allow this communication based on layer 3, layer 4 information.